Today's map is the record of a glorious failure in science. Our author is one of the greatest names in the history of the natural sciences, and the map addresses one of the thorniest problems in the science of the day. The map itself is technically outstanding. It's the collaboration of one of Europe's greatest cartographers with the world's preeminent natural scientist. In many ways, it's a great example of the scientific method. But in one particular way, though, it's a cautionary tale, a fable worthy of Aesop, illustrating how smart scientists can do very bad science. You see, most of what's new and interesting on the map is completely, almost laughably wrong. Welcome to the Eye of History, where we are about all things maps and map collecting. Here we learn history by studying the maps of the era. We look at the history of the map and the history on the map. And if you are as interested as I am in experiencing new perspectives on historical subjects, then please like, share, and subscribe. It really helps niche channels like this one. The year is 1850, and the map is a geological exploration of Europe. The map is in German. It's published in the Berghaus Physikalischer Atlas. And as you can tell from my pronunciation, I don't read or speak German at all. So thank goodness for Google Translate. Now, if you read German, please look at the scan yourself and let me know if I misunderstood anything. I put a link in the description for you. I bought this map because it's an early example of a stratigraphic map. Instead of showing countries, it shows the dominant geological stratum, that is, the age of the rocks that can be seen there. But before we get into the stratigraphy, let me set the scene for you. By 1850, geologists had worked out the basics of stratigraphy. If you want the whole story in tremendous detail, I highly recommend the writings of Martin Rudwick. I'll leave the links in the description, but I cannot recommend these books highly enough. You will learn a tremendous amount about geology and even more about how science actually progresses. Now, the geologists at this point knew the Earth was ancient and that it experienced long epochs that can be distinguished by the fossils they left behind. Louis Agassiz had recently written about his theories of an ice age, but many hadn't heard enough about it for them to abandon the long-standing theory of the globally catastrophic flood. Geologists recognized that mountains grew and were eroded away, but they were flummoxed to explain why. Now, of course, they knew that some mountains were created by volcanoes, but clearly most were not. And you have to put out of your mind any thought of plate tectonics. Plate tectonics didn't even rise to the level of a crackpot theory until 1931, when someone finally came up with a reasonable mechanism that might explain it. And honestly, that explanation was mostly wrong. The actual mechanism wasn't understood until the 1960s. So the question of how mountains were created, the question of orogeny, was one of the greatest scientific mysteries of the era. Leading the charge to discover the answer was a man considered among the greatest natural scientists in history, someone that Darwin himself felt indebted to, a German polymath by the name of Alexander von Humboldt. Humboldt lived a long life, and he used it to travel the world. When he finally settled down, he endeavored to write down everything he learned in what became a 5-volume text he named Cosmos. And the work covered virtually all of natural science: meteorology, geology, what is sometimes called biogeography, that is to say the study of what lives where and why. He was the type to get his hands dirty. In one adventure, he risked his life to collect electric eels, and he dissected them and received some potentially fatal shocks. He made novel contributions to every area of natural science. He is called the father of seismology and of ecology, and more species are named for him than any other human being. Today, he is hyped for having observed and writing about human-induced climate change, this in the 19th century. In writing Cosmos, he collaborated with many other scientists, vetting his ideas and honing them for publication, and he also collaborated with one of Europe's best geographers, his friend Heinrich Berghaus, who created an atlas to accompany Humboldt's Cosmos. Cosmos was a sensation, the most influential scientific work between Newton's Principia and Darwin's Origin of Species. It sold better than both of those. And Berghaus Atlas also sold very, very well. And of course, that's where our map comes from. This map's going to show us Humboldt's theory of mountain formation. And it's also going to show us how even a scientific giant like Humboldt is capable of giant error. We have before us a two-page spread from the Berghaus Atlas, with a map of Europe in the center, and various tables of information arranged around it. As we look at this, we'll start on the left side of the map, with this chart. We'll zoom in here, and even if your German is as bad as mine, you might notice some words in here that sound vaguely familiar, maybe something you learned in a high school natural science class, or maybe saw in the movies. Because I see a couple things like Trias and Jura, which sound vaguely like Triassic and Jurassic. Well, that's not a coincidence. What we have here is a table of the different strata that had been identified by this time. Each of these represents some characteristic sediments that you would find in the same order wherever you found them. The key discovery came when scientists in London and Paris discovered that the sediments in their respective areas were remarkably alike. Once that basic discovery was made, of course, they immediately set out to see if the rest of the world had the same set of sediments. What they found was when this was true, it was largely true. And when it was false, it was entirely false. That is, there were large swaths of land where the sedimentary layers were beautifully preserved. And there are portions where the layers were there, but jumbled up as though they were created and then massively distorted. And there were areas that didn't have any sedimentary layers at all. So for the 50 years or so previous to the creation of this map, this is what geologists were working on, especially since they discovered that one of those layers was made up almost entirely of coal, which was the fuel for the brand new steam engines that were powering the new industrial revolution. Everybody, everywhere, wanted maps like this one. Now, this map is too small of a scale to tell you where the coal is going to be, but it does show regions where it definitely isn't. And the legend on the left explains the concepts fairly thoroughly. Zooming into another part of the table, we see the term diluvium used for the most recent gravels and sediments. Now this term, of course, references the great flood that was once believed to have occurred, and it's a little surprising that Humboldt and Berghaus would still use this term. There's no question Humboldt was aware with Agassiz's theory of the so-called Ice Age. It was one of the hottest topics in geology at the time. And he was well aware that climate varied over time. He himself had discovered mammoth teeth in equatorial South America. But apparently Humboldt was still not completely convinced by the arguments for an ice age, so he kept to the older theory, or at least the older terminology. Another interesting feature is that much of the land is colored in the same gray as the seas. In the text, it explains that these were areas that they thought were largely, possibly intermittently, underwater in recent times. And some of this is accurate, such as around the Caspian Sea. However, most of this territory was simply not yet studied thoroughly enough. In this era, geologists could only see what they could see on the surface and occasionally in mine shafts and cuts made for canals. And so we shouldn't be surprised that a large, flat region with few minerals, such as northern Poland and Germany, weren't properly understood. The irony here is that Humboldt lived in Berlin. The geological province he knew least about was his own home. One last feature before we get to the main event are these two sets of lines. Here we get to see Humboldt's interest in seismology. One line shows the effects of a volcanic eruption in Iceland. The other shows the extent that the Lisbon earthquake of 1755 could be felt. Humboldt honestly gets way too much credit in this area. The real work in this area was being done by people that you've probably never heard of, but history has a strong bias towards celebrity. So it's Humboldt that's often called the father of seismology. All that was interesting enough for me to justify my purchase, but it was this diagram at bottom center that got me truly excited. It almost looks like some sort of astrological map, a geological horoscope. It's essentially a compass rose, but with rays in all directions, and each ray labeled with the name of a mountain range. It took me quite a bit of work with Google Translate to unravel its mystery. I didn't expect it to be tied to the most important question in geology of the last 2 centuries. It turns out that this diagram was intended to be Humboldt's proof of one particular theory of how mountains form. Remember, plate tectonics was not a theory that anyone in 1850 could rationalize. It was almost inconceivable that the Earth's mantle was molten. Volcanism was considered a near-surface phenomenon. This was not for lack of imagination, it was simple physics. The Earth had to be cooling. The Earth had to have begun as a hot ball of molten material and had to have been continuously cooling ever since. Then the solid crust getting thicker and thicker as time went on. Only a crackpot would theorize that the Earth had some sort of internal heat source that could keep the mantle molten. At least, until radioactivity was discovered. What was Humboldt's theory? And I should point out that this theory was not exclusively his, but was something of a general consensus. It combined two observations. First, cooling solids generally shrink. And if we're talking about a solid as large as the Earth, even a tiny shrinkage would have enormous effects. Imagine if you put an unbreakable belt around the equator and then shrank that belt by 0.1%. That belt would squeeze the Earth and create a canyon 6 miles deep all the way around. Now imagine the whole Earth shrinking by 0.1%. Now, since the Earth is not entirely homogeneous, it's not going to be completely even. Some areas are going to shrink more than others. And these differences will manifest at the surface in the form of giant chasms and new mountains. Just the sort of orogeny, mountain building, that Humboldt was looking for. Second, the world has experienced multiple epochs, distinguished by different sediments as well as different life forms and climates. And it's these sediments that fascinated geologists. Why would each epoch have distinct sediments? Now, since sediments are the products of erosion, the only logical reason would be that in each epoch there were new and different rocks exposed to get eroded, which in turn suggested that each epoch represented a cycle in which new mountains were rapidly built up and then slowly eroded down over and over again. That would create this marvelous parfait of varying sediments, consistent all across the world. This all seems logical, but unfortunately it's hardly a testable theory. All the stratigraphic record could prove is that not all mountain ranges were thrown up at the same time, and there was no way to prove that the cooling of the Earth provided the motive force. Our map, though, suggests that Humboldt came up with a way to test this theory. The key observation was that cooling objects do not deform randomly. There is a pattern to be observed. Here we have before and after photos of a spheroidal object that has been subjected to a small amount of subsurface shrinkage. The photograph clearly shows that most of the shrinkage is expressed in wrinkles. Compare those wrinkles to this mountain range as viewed through Google Earth. The similarities are striking. This certainly suggests that the general theory is correct, but Humboldt and Berghaus noticed something else about those wrinkles. They're parallel, or at least very close to it. And that's the key idea. If the entire Earth shrinks periodically, then mountain ranges formed each time should be parallel to each other, or at least mostly so. And that's something we can test. We just need to catalog when all the mountain ranges were formed and see whether the ranges formed in each period are in fact parallel to each other. Brilliant! And if we look over here to the right, we see a table with 13 rows and 3 columns with exactly the information we need. Even without Google Translate, I can recognize the names of various mountain ranges in the second column. And in the first column, Google Translate tells me that nach dem means after and vor dem means before. So for the first group, column 1 reads after the Cambrian and before the Silurian. In this group, according to the second column, there are 11 mountain ranges in Europe. And according to the third column, it says that they all line up in parallel 35 degrees from east-west. 5 other ranges are also listed that don't fit the pattern. So let's give the authors credit with honesty as they give the counterexamples full treatment. Now this chart works its way through 13 groups, each representing a different epoch. And it turns out that the counterexamples are pretty rare. Now, of course, our theory allows that there'll be some exceptions, but that does seem an implausibly small number here. But as they say, quod erat demonstratum. The epochal cooling theory predicts mountains created in the same epochal event will be parallel. And they are. The figure at bottom center adds an extra element to the theory. It shows that there's no particular progression or pattern to the directions. So each epochal cooling period is entirely independent of the previous period. That implies that it wasn't a continuous process. There must have been a mountain building period, presumably rather brief, geologically speaking, followed by a much, much longer period of erosion and sediment creation. It fits together so beautifully. But today we know it was never true. So how did this go so wrong? What is wrong with this proof? Well, it's simply bad science, and bad science for two different reasons. First, it's an outstanding example of how careful you need to be when collecting data. It's so easy to nudge your data in the direction that favors your theory. Anyone should have been suspicious by the precision of the angles. In System 10, are the mountains of Corsica and Auvergne really aligned due north and south like it says in the chart? A quick look at Google Earth shows that it's not nearly so exact. In fact, is this even a legitimate measurement? Mountain ranges curve, and there's ranges within ranges. Looking at a large enough scale, the Rocky Mountains align more or less north and south, but within the Rockies, the Uinta Range aligns directly east to west. So where do the Rockies fit within this chart? And as for the ages of the mountain ranges, they seem rather arbitrary. As far as I can tell, they were based on the relative level of erosion. Stark Alps with jagged heights and steep canyons must be young. Soft rolling hills must be old. Now that theory works in a lot of cases, but there are many, many exceptions. And it's hardly precise enough to allow all the world's ranges to be split into 13 precise categories. So Humboldt and Berghaus had two ways to nudge the mountain ranges into the correct categories. They could fudge the measurements of their angles, dividing ranges that don't fit the pattern into smaller ranges that do, or cheating as they read their protractor. And they could fudge the estimates of their age. That made it all too easy to get the results that they wanted. Not that they were being intentionally dishonest. The fact that they included some exceptions suggests that they were sincerely trying to be objective. But this happens all the time in science, to the point that today many scientific fields are experiencing a replicability crisis, where much, even most of the results reported in journals can't be replicated by anyone else. Yet many of these studies live on. Some are even cornerstones of their field. So, one of our great scientific heroes is guilty of biasing his data. That's so commonplace that it's hardly worth recording a YouTube video. It's his second mistake that makes this video worthwhile, because it's one of those situations where the great scientist missed something that a clever school kid could have caught.
He's intelligent, but not experienced. This pattern indicates two-dimensional thinking.
You see, angles on a sphere don't work quite the same as angles on the flat printed page. Humboldt and Berghaus looked around Europe and around the world and measured the angles of mountain ranges against the equator, and they visualized them as being parallel if those angles were the same. That's perfectly valid if that angle is 90 degrees. This graphic gives us an idea of what that might look like. We call these parallels meridians. But for any other angle, we get something very different. These lines are called loxodrones, and as you can see, they don't make a neat set of parallels. For Humboldt's idea to work, the Earth would have to twist in a very unusual way every time it shrank. That would be the only way to create these spiraling loxodrones. Note how the closer to the poles, the more it has to twist. If drawn accurately, the loxodrones actually spin around the poles an infinite number of times. It's all quite absurd. And so the entire demonstration comes crashing down, built as it was on an elementary misunderstanding of spherical geometry. We can now see that the data in the table is not just a little bit biased. It might as well have been completely fabricated, seeing as it fits the theory so well, despite the theory being mathematically absurd. Of course, this didn't discredit the general theory of periodic cooling. It just utterly failed to provide any support to that theory. The theory itself would survive another 50 or 60 years until the early 20th century. Only then did it become clear that radioactivity was keeping the mantle hot and fluid, and the Earth was not shrinking. And of course, this did next to nothing to dent Humboldt's reputation. Set against the long list of Humboldt's achievements, a failure like this is easily overlooked. And that's just fine. Science requires failure if it's going to advance. As for the map itself, it's a vivid and graphic record of a humiliating mistake committed by one of history's greatest scientists. What is that worth in the marketplace? Not as much as I think it should. Berghaus's physical atlas was very successful. In fact, just about a decade ago, they published a reproduction version, which you can find today on Amazon in paperback and hardcover. You can still find original atlases available for sale by book dealers, auctions, eBay, but be careful as they printed several versions with various levels of completeness and quality. The full version will put you out at least $1,000. Lesser versions can be just a couple $100. Individual maps are easy to find, although finding any specific map can be a challenge. My specimen is in excellent condition, but regardless, its market value is well under $100. It's yet another case where the marketplace and I simply disagree about the value of a map, which is all to the good and is where much of the fun of collecting resides. Again, like, subscribe, and share, and see you in the next video.